Before any test or model, look at the distribution. A histogram answers the most basic question about a variable. How are its values spread out? Here's list price. You read 4 things almost at once: where the center is, how wide the spread is, the overall shape, and any outliers. This one has a single peak and a long tail to the right. It's right skewed. A histogram has one crucial knob: the number of bins. Too few, and you smooth away real structure. Too many, and every bar is just noise. Stratum puts that control right here so you can feel the trade-off as you drag it. You don't have to guess, though. Rules like Sturgis, Rice, and Friedman-Diaconis pick a sensible number for you. For skewed data, Friedman-Diaconis usually behaves best because it keys off the middle of the data rather than the extremes. Bins are a bit blunt, so let's add a smooth density curve. It traces the same shape, independent of where the bin edges happen to fall. Many methods assume data is roughly normal, so Stratum can overlay a normal curve with the same mean and spread. If the bars hug it, you're close. Here, the long tail pulls away. Clearly not normal. And notice, on a right-skewed distribution, the average sits to the right of the peak, above the median. That's the visual definition of skew, and your cue to treat averages and normal-based tests with care. One distribution is useful, several side by side is better. I'll split by property type, and Stratum draws a gallery of small multiples on shared axes, so I can compare them at a glance. When the chart says what I need, I export it to PNG, JPEG, or a vector PDF, ready for a report or a slide. The histogram nails a single variable. Next, we'll compare many groups at once with box and violin plots.